Grade 12, still continuing with exercise 9.3. I'm now going on to question 5. Okay, so it says here the graph of y is equal to ax cubed plus bx squared plus cx plus d touches the x-axis at -1. So we know that's -1. I just want to mark that here. Okay, and cuts it at 1. So we know that point over there is 1. And then the y-axis at -1. The straight line intersects the cubic graph on the x-axis as shown. So it intersects over there in the diagram. We need to show that A is 1, B is 1, C is -1, and D is -1. Okay. Right, so question A, we've got f of x, which is equal to y, which is equal to ax cubed plus bx squared plus cx plus d. Okay, and what they've given us here, if we have a look, we've got an x-intercept here. So we've got 1 times x-intercept. And remember, if your graph turns on the axes, you've got 2 times x-intercepts. Okay, so what they've given us here is they have actually given us 3 x-intercepts. We've got 2 over there and 1 over there. So what I'm going to do is I'm going to be using this equation. Y is equal to a x minus x1, x minus x2, and x minus x3, because we've got our x-intercepts. Okay, so if I put this one in, I'm going to get x plus 1, because the minus and the minus will give us a plus. So we get y is equal to a x plus 1, but remember we have 2 of them. So it's x plus 1. So that's for those ones. For this one over here, if I put the 1 in here, we're just going to get x minus 1. Okay, now we need to find out what this a value is. Now, in order to find that a value, I'm going to substitute a point in. And the point that we have is this one over here, which is 0 minus 1 for our y-intercept. So I'm going to be substituting in 0 minus 1. So our y value is 0. I beg your pardon, our y value is -1. And our x value is 0. So we get 0 plus 1, 0 plus 1, and 0 minus 1. Okay, so we get here -1 is equal to, that's going to be 1 times 1 is 1, times -1 is -1, which gives us minus a. So that means that a is equal to 1. I'm now going to take this a value and I'm going to put it back into this part over here. Okay, so we get y is equal to 1 multiplied by x plus 1, x plus 1, x minus 1. So 1 times this thing here is still going to be that thing over there. And then what I'm going to do, grade 12, is I'm going to FOIL these last 2. So we get y is equal to x plus 1. And if I FOIL this out, I'm going to get x squared minus 1. Now I'm going to distribute this x into both terms and that 1 into both terms. So y is equal to x cubed minus x plus x squared minus 1. I'm just going to rearrange it in descending powers of x. Okay, so the a is in front of the x cubed, so a is equal to 1. The b is in front of the x squared, so b is equal to 1. The c is in front of the x, so c is equal to -1. And the d is just your constant term, so d is equal to -1. So, and I think that's what they wanted us to show, that a is 1, b is 1, c is -1, d is -1. And that's what we've got. Okay. Right, so the next part of the question is determine the equation of the straight line. So we need to determine that over there. Now, I know 2 points on the straight line. I know this coordinate, which is 0, minus 1. And I know that coordinate over there, which is 1, 0. So I'm going to try and fit it all in here for you guys. So y is equal to mx plus c. We've got 2 points. The one is this 0, minus 1, which was the y-intercept. And we have that other x-intercept, which is 1 and 0. To find this, we use the gradient formula. I'm going to substitute these points in here. So we get m is equal to 0 minus 1 over 1 minus 0. So that will give us 1 at the top, 1 at the bottom. So m is equal to 1. Okay, I'm just going to continue on the next page. So now that we know m is equal to 1, I can do this. Y is equal to 1x plus c. Remember, we're using this formula y is equal to mx plus c, and we've just worked out what the m is. Now what I'm going to do is I'm going to substitute either one of these points in. I'm going to substitute the top one in. So I'm going to substitute the point 0, minus 1 in. So y is minus 1 equals 1 times 0 plus c. So that means that c is equal to minus 1. Therefore, y is equal to, now I don't have to write 1x. I can just say x minus 1. And that is the equation of that straight line. Okay. Question C. Determine 2 points on the cubic graph that will have tangents perpendicular to the straight line. So what we want to do here, grade 12s, is we want to find the gradient that is perpendicular to this one. So we've got m is equal to 1. That's the gradient for that. Now remember, for lines that are perpendicular, we are going to use this. m1 times m2 equals minus 1. Okay. So I'm just going to plug that into here, and we get 1 times m2 for our second line equals minus 1. Divide through by the 1, so we get m2 is equal to minus 1. So we need to have a gradient of minus 1. And we want to know where would this gradient of minus 1, whatever the line is, where will it touch our cubic graph? Okay. So now that we've got the gradient, remember how we find gradients? We differentiate. Okay, so now that we know what A, B, C, and D is, I can put that back into the original up here. And we are going to get y is equal to, A was 1, so we get x cubed. B was 1, so that's plus x squared. C is minus 1, so it's minus x. And D is minus 1. Okay, so what I'm going to do is I'm going to differentiate that. And once I've differentiated that, that is my gradient function. So dy dx equals 3x squared plus 2x minus 1. Now what we're interested in is finding the x values that will give us this gradient of minus 1. So I'm going to set my gradient function equal to the minus 1. So 3x squared plus 2x minus 1 equals minus 1. And what that will do, it'll find the x values to give me that gradient of minus 1. So let's just take that to that side, and we get 3x squared plus 2x. They will cancel, equals 0. I can now factorize this, and then I can solve. So we get x is equal to 0, or x is equal to minus 2 over 3. Okie dokes. So what we're going to do now is, I just want to see what the question was, determine 2 points. So what I need to do now is I need to take that and put it back into the original to find out what our corresponding y values will be. So for this one, I'm going to put it into here, and we get y is equal to 0 cubed plus 0 squared minus 0 minus 1, and y is equal to minus 1. Take this one, put it back into the original to find the y value. So y is equal to minus 2 over 3 cubed plus minus 2 over 3 squared minus 2 over 3 minus 1. Okay, put that on the calculator and you should get minus 5 over 27. So the 2 points that will have the same gradient as minus 1 is 0, minus 1. And the other one is minus 2 over 3 minus 5 over 27. Okay. Then question D. For which values of x is the cubic graph concave down? So you remember, for concavity, this is question D. For concavity, for concave up, your second derivative will be greater than 0. For concave down, your second derivative will be less than 0. Okay, so all I'm going to do is I'm just going to find my second derivative, and they want it to be concave up. So this, concave down, which is this one here. So I'm going to set my second derivative less than 0. Now an easy way of doing this, guys, is we can just say f of x equals y, which is equal to, and I'm just going to use the function that we had. So that was, let me straighten this up, which was x cubed plus x squared minus x minus 1. So I'm going to find the first derivative. So f dashed of x is equal to 3x squared plus 2x minus 1. Find the second derivative, which is 6x plus 2. Now, for concave down, which is this one here, we need to take our second derivative and set it less than 0. So that means we get 6x plus 2 less than 0. So 6x is less than minus 2. So x is less than minus 1 over 3. And that's where your graph will be concave down. All right, great. Well, thanks.